In standard cosmology, there are figures such as measurement of luminosity through absolute magnitude, which is a common calculation and possibly does not have any ensured accuracy because there are no reliable tests to determine the figure. Astronomers calculate the brightness of stars as they would appear if they were 32.6 light years or 10 parsecs from Earth. This is a metric called absolute magnitude. Absolute magnitude is strictly a hypothetical number because there's no way to measure all the stars in the universe at exactly 10 parsecs away. Possible hypothetical figures like absolute magnitude could aid cosmologists by helping to supply data figures with a degree of consistency. Another measure of brightness is luminosity, which is the power of the star. This is measured by the amount of energy or light that a star emits from its surface, according to space.com. There are also metrics to detect luminosity as well. Type 1a supernova are used as standard candles to detect luminosity, according to Alan Guth at MIT. When calculating apparent brightness, luminosity, distance, temperature, and surface area, which are representations of variables in the calculation of starlight. Every one of these variables has a degree of difficulty and inaccuracy that affects recorded data sets. For example, luminosity is not alone proof of distance. Within the two measurements that scientists use to prove luminosity and redshift, the second observation of starlight, in which astronomers gather luminosity figures in standard candles by the recession or accession of light with respect to time, those measurements could be skewed by hidden variables like astronomical dust, gravitational lensing, light refracting or being blocked from astronomical obstacles, atmosphere like ours that scatters light in the form of sunset orange light and daytime blue light. Also, other potential variables that make measurements a difficult task and the lack of the ability that we have to take proper temperature readings and the lack of being able to get in proximity of the luminous object because of too large of a distance or extreme temperatures. Cosmologists measure two different wavelengths or frequencies. Then another hypothesis that explains some of the observations of redshift data could be the Earth's movement along its orbit, either approaching or receding from other planetary bodies or stars. It is hard for Hubble Space Telescope, a source of redshift data, to predict an orbiting pattern either of a massive star or other planetary bodies. Even getting two of the same observations from our Earth with everything else held constant, such as all the celestial bodies and the planet in the exact position twice for a redshift measurement, is about impossible, unless you have an optical viewpoint away from the Earth's atmosphere, such as the Hubble Space Telescope. Even that does not stay in the same place long enough to get separate measurements to compare. Even solid planetary bodies located in the galaxy system could be stopping part of the light without us even knowing about it. The possibility of extra gravity over and above lensing could create impedance of frequency, causing a redshift effect when analyzing the difference of hues with respect to time. Another reasoning of why the discoveries of sky surveys measure visual redshift in the galaxy could be because of an ionization process of stars that change intensities and the color within the star and thereby change the star's light emissions. There could be an integration of heavier gases such as hydrogen or helium. In the identification of gases, it is current cosmological theory that if the same pattern of intervals is seen in the above spectrum from a distant source but occurring at a shifted wavelengths, it could be identified as a particular gas. Hydrogen is the most abundant element in the universe, accounting for about 75% of its normal matter. Stardate.org. With the morphology of distant galaxies, the constituent light patterns could be visually changed on the basis of the amount of hydrogen that the light needs to go through before it is observed by a telescope. Due to these orbiting anomalies, which could cause varying frequencies and wavelengths of light patterns, the recording of redshift bodies may need to be reanalyzed or further investigated. These events of recording redshift are primary pillars to the origination and proliferation of the current Big Bang model of galaxies moving away in the cosmic microwave background. They may be true in some realms, but incomplete in the explanation of the true nature of the cosmos. The Hubble Space Telescope, most notably, along with ALMA, the North Pole Expedition, and all the sky surveys, are great feats in human intelligence, and the purpose of this paper is not to degrade their work or thwart funding to those projects, but is to shape the analysis and offer other conclusions than the current conclusions and accepted theories of galaxies moving away and the microwave background cooling of academia. There is no experiment that I'm aware of that measures redshift on Earth strictly in waves that are not gravitationally induced. Redshifts can and should be investigated by top universities, proving its validity in its Doppler-like integration of light waves. There may be a critical speed in which redshift stops occurring from sound to the electromagnetic spectrum. There are clearly means to measure an object's speed relatively accurately, such as radar and LiDAR guns, that will measure speed of the object at lower than light speeds and in small distances. Those machines work and are dependent on mechanized knowledge of the light emitted at small distant intervals and knowledge of the frequency shifts that the beam causes depending on distance. This is comparatively and systematically different than capturing light from a distant galaxy and calling it redshift. Yet it is true there are many measurement experiments that can accurately predict time dilation using atomic and light clocks easily. It is logical that we should be able to easily measure redshift in waves accurately on Earth with moving bodies and bodies at rest over long distances. Possible experiments using moving emitting bodies and receivers, such as cars or jet airplanes emitting frequencies in waves over certain velocities, could prove just how light behaves and just how far does the universe stretch. Measuring waves of redshift and blueshift is well within the confines of our human intellect to conduct experiments in proving that I am incorrect or correct in my assertions.